Hey, this is Ryan Jones from Serverless Guru. This is the continuation of part one where we started implementing a serverless plugin using the Serverless Framework. In this video, we're going to be covering part two of that blog created by Anna, and then we'll run through it, see what we can find out, and then we'll start actually implementing our own. So let's go ahead and dive into it. So the first thing, let's see, follow-up post to the first one we wrote, or to the first one that we created, which is great. And then extending the serverless framework. Plugins extend functionality of the framework to tailor to the use case. So if you didn't see the first video, definitely watch that first, but also you can check out training.serverlessguru /courses/serverless plugins, and we have 10 videos. I think we cover about 8 different plugins which are useful. Also, you can check out the community plugins video here where we cover basically where you can find the plugins for the serverless framework and which ones we recommend. There's also things like smaller package size, .env support, nested stacks, building a website. There's infrastructure ones like removing S3 buckets, which is really important, removing Lambda versions, and then testing. So unit testing with serverless Mocha plugin. These ones are pretty interesting, and we'll probably release more of these videos soon, or sooner rather than later. So let's go ahead and switch back. So all those plugins that we just saw here, these are just kind of a snippet of them, but each one of these has a specific role, and that's why we chose to create videos about it. This one is for creating a website. This one allows you to extend the serverless framework to do even more on the automation front. This one is for nesting CloudFormation stacks together. Smaller package size. This one allows you to reduce your package size when you're actually deploying to Lambda. Some of this, they came out with Lambda layers recently, and that may be a better way for you to actually reduce the package size, but at least on the code that you're uploading, this one could actually save you a little bit more space. So then .env support. So if you want environment variables, you want to inject those into the Lambda functions during deployment and keep it out of source control. A typical way that people do that for Node.js is using .env. So you can use this plugin here to actually add environment variables to your Lambda functions in the same way that you would do a regular Node.js like Express application. Sweet. So let's get back to it. So allows you to take different approaches to implementing your logic. The main ways are you write a new command. So for us, that was like the welcome command, and then extend an existing command to implement additional functionality. This one's interesting. What's being talked about here is that tapping into something like, let's go up. That's like tapping into something like serverless deploy. So imagine you want to add some extra functionality to the serverless deploy command. You should be able to do that with by building a plugin which hooks into it. So that's pretty interesting. And then writing your own implementation of an existing command from scratch. So if you want to completely start over and just do something, you can completely do that. It's very flexible. So let's start with writing a new command. So let's have a look at a practical example, illustrate this. So imagine you have a microservice defined in your serverless.yaml that contains a DynamoDB table. You can deploy the functions, add API gateway endpoints, and create the table automatically by running serverless deploy. What if you want to copy data from production to a dev table so that you can test your application with real data? You can export and import from one table to another, but that'd be very tedious if done frequently. Instead, we can write a plugin. Copy data plugin. So you can start by defining the command in a new class as shown in the part 1 series. I imagine the command would have 2 steps or lifecycle events, one for downloading the data and one for uploading it. It could look something like this. So you can see here that she's created a class called copy data plugin. It's got a constructor with 2 options, and it has commands. So if you run serverless copy data, copy-data, it'll run these 2 lifecycle events. The first one, download data. The second one, upload data. And if you run serverless copy-data -help, it'll pull up this one that says basically it pushes data from one database to another. And at the very end, you always have to do this module.exports, so keep that in mind. When the command is defined, you attach lifecycle functions by defining them as hooks. Again, one function will handle downloading the data and the other will upload it. Notice that we're binding serverless and options to these functions so that they can access their data. So we can see here, class copy data, constructor, went through that, lifecycle events, usage. But now we have this thing on line 14 called this.hooks. And it has two hooks. One is copy data, download data, and it will then run download data dot bind, and it's passing in some arguments. This one will run copy data, upload data. This is another hook, and it will run upload data, and same thing, it passes in these arguments. So you'll have an object-oriented programming approach, so that would be like this class-based thing. So if you'd rather not bind serverless and options to these functions, there's another more object-oriented approach. So this would be the version 2, that same thing above. This is binding it to class variables. So now this.serverless and this.options are attached to this class copy data plugin, excuse me. And then this.commands, don't need to see it, this.hooks. Now it's a little bit different. So you can see this.download data.bind this. So I actually prefer this approach, I think, using the OOP or object-oriented programming approach. It makes it a little bit cleaner. And then you have your functions down here, download and upload data. Or if you're using Babel and like cutting edge ES features, you can use class properties transform to use arrow functions and remove the need of binding completely. I like that even better. So this.serverless equals serverless, this.options equals options, class variables, and then this.hooks. Now instead of doing any argument passing, we're just saying this.download data, even better. And you can see here we got our fancy arrow functions. So this is probably what we're going to opt to do. It's great that she kind of broke that down into 3 different parts. I would personally prefer a more functional approach. That's why we'll carry on this tutorial with the 2 functions completely separate from the class itself as per version 1. So she's not going to do that. We'll probably do it this way, I think, for our own stuff, but we shall see. Downloading data. First, you want to download the data from a production database and save it somewhere so you can upload it in the second step. I decided in this case to save the downloaded data to serverless.variables so it can be easily accessed. So here we have this thing called download data. This is our function. It's being passed 2 arguments. It's a promise. It's going to say configuring the AWS SDK and getting the DynamoDB client. So it's saying get DynamoDB from this thing here, serverless. And then we give it a params with the table name. Then we say DynamoDB scan. And it's going to have params, which is this table name here. Has 2 things coming back in the response, error and result. Because if it's an error, then log this error on downloading data, and then return an error. Otherwise, we can use serverless.variables.copy data. So this is us adding copy data into the serverless.variables object, and we're setting it equal to result, which is the successful response of scanning DynamoDB. The last thing we do is we say that we downloaded it, and you can see here she's doing a json.stringify of the result, which is coming back here. The result from DynamoDB.items. Every time that you scan from DynamoDB, it comes back with an items object, or an items array, sorry. And then inside of that, it's either an items object or array. I think it depends. It might always be an array, unless you have like 1 item, I'm not sure. And then .length. And then it says the total length of the amount of items that we just scanned. And then finally, it resolves that result, and so that would be the full download data function. So yeah, let's keep going. So as downloading is an asynchronous event, your function needs to return a promise. This way the serverless framework will know to wait. Another handy thing to notice is a CLI.log function provides a way to uniform messages to the console. In your implementation, you can easily swap DynamoDB for another database or even a provider entirely. However, now we'll stick with AWS, the most widely used provider. Yep, true. So uploading data. In the second step of the implementation, we simply need to take data from serverless.variables.copy data and upload it to the test/dev database. As far as I'm aware, we can only do that by uploading the data 1 by 1. So you can see here she's going to do a put item. You might be able to do a batch put item. I'm not entirely sure, but maybe. So get put promise, DynamoDB, params, serverless. DynamoDB.put item, and then we say that if it's successful, we say that it uploaded. Otherwise, we return reject an error. Upload data. This was the one that we already think. This is the upload data one that handles actually sending it up there. So let's go ahead and look at this. So it's passed serverless and options similar to download data. And then it is also a promise, so it has a resolve and reject. So if it's successful, resolve. If it fails, reject it. And then we can do const DynamoDB, get DynamoDB serverless, and that will actually return back a DynamoDB object, which we can actually use to then run commands like put item. Then we have uploads. So the first thing we're going to do is go into the copy data. Remember, we did a DynamoDB scan up above, and then we inserted this entire result object. So you can see serverless.variables.copyData is equal to result, and then result.items. So inside of this result object is something called items, and that items is an array. You can see here that she takes that array, copyData.items, and then does a for each loop, and then each loop in that is going to be a single record in the database in DynamoDB. So then table name item data. So this is basically saying now put this into another database. Uploads.push, and this is basically saying here's the uploads array. Push meaning add something to it, and then get put promise. So this is basically adding a promise to this array, and then this get put promise will then run DynamoDB.put item. So this is a really great way to do this, in my opinion. She's looping over the items, and then she's creating an array of promises. And then down here on line 24, she does promise.all uploads, and then .then, and then after it's done, logs data uploaded successfully, resolve, data upload failed, reject. So that was a really good use case for actually showing how to pass data in between these two different lifecycle hooks here. So in one of them, in the download data part, the data is copied, or it's basically scanned from a database running on AWS, and that's saved as result. And then result is saved underneath serverless.variables as copy data. And then in the second lifecycle hook, where their lifecycle event, we're then able to tap into that by running upload data. And when upload data runs, it loops over those records, creating an array of promises. And then finally, it executes all that array of promises in parallel. So if this was 100 different records, and you have to make 100 requests to DynamoDB, you don't have to do them sequentially, like one at a time, like the first one, second one, third one. It just does all of them at the same time. So meaning if one request takes 1 second, then you could finish 100 in 1 second versus 100 seconds if they were run one by one after another, like sequentially. And then we're done. Cool. So somehow this doesn't feel quite satisfying. Why should this be a serverless plugin when really we could write this easily as a Node or Bash script? That is a really important question, and this is something that often I've opted to create Bash scripts. So let's see if I can be convinced as well. To see where the serverless framework helps us, we need to dig a bit deeper. Generally speaking, it contains whatever we specified in the serverless.yaml. To give a few practical examples related to our case, region, default state, and custom variables, service resources. If we look at the implementation of get DynamoDB, some of its benefits become immediately obvious. So const AWS, get DynamoDB, serverless, AWS config update, serverless.service.provider.region. This is nice, and what's being pointed out here is that otherwise you would have to know what this is. This plugin is basically picking up these values directly from the local computer. So we have a file called AWS, it's underneath the .aws folder, and it's called /credentials. And credentials hold your region. It also holds your access key and secret access key that allow you to actually get into your AWS account. So this is important because this is automatically configuring that for you without you having to worry about that. So that's good. Then it returns an AWS DynamoDB object that we can then work with, like doing the scan or the put item. Getting region from the serverless object makes our plugin more resilient. So that means that it's dynamic. If we decide to deploy the service to another region, the plugin will still work. And so this is important to point out as well. The way that I just said that may be slightly off. Basically, you can pass a flag into the serverless command. So you can do something like that. So then this will automatically pick that up and deploy, and then your DynamoDB commands will go against that region versus going against like US West 1. Now, there are scenarios where, like we've had where a service like Cognito is only supported in US West 2, but then all of our actual Lambda functions and all that are in US West 1. And so something like this, we would want to deploy to our stuff to US West 1, but then on this edge case, we would want to reference something from US West 2. This is where this part can kind of get a little bit hairy from our experience building the client projects with the serverless framework. So it also makes useful of our particular service. We could use it across our code base or even open source it nearly. Defining a stage. Our plugin is so far really useful only if I have a users table deployed to production and dev. I might also want to use it for customers, moving data from test to dev for debugging and testing purposes. We've already used region to configure the AWS SDK. For others, we need to first consider we might have defined in the serverless.yaml file. One of the typical setups would be to have a default stage that can be optionally replaced by passing -- stage. So this is important. I go through this on the training site. If you go to all courses, and then you flip over to serverless introduction, and you look at the course curriculum, you should see something here on dynamic variables. So if you haven't, I would definitely check this out if you're interested in the serverless framework. This is a pretty, I would say it's a good introduction to like using this stuff, and dynamic variables, serverless commands, how to organize a serverless project, all those ones. So we'll cover this. These are using these like dynamic variables here. So option stage, self-provider.stage. And what it basically does is that if you pass -- stage, this will then go to this value here. So it'll be replaced. So option stage will be replaced by -- stage. The value that comes after it, of course. So yeah. So if you pass -- stage dev, option : stage will then become dev. We are now sure we'll have a stage specified whenever we're running serverless commands. This allows us to swap users -- production for more generic formulation. What that's basically referring to is that in this case we would have two databases. The first one would be dev, the second one would be production, and the way that we specify those two different databases is by passing this -- stage flag. So if we pass -- stage prod, then it should look at the prod database. If we pass -- stage dev, it should look at the dev database, and then that will allow our plugin in the background to then point at the correct database to transfer the data accordingly. So yep. And then so we're now able to make it more generic. So we can see download data here, and we have serverless and options, same as above. And then we have a promise, which will resolve and reject. So DynamoDB, get DynamoDB serverless. That will create the DynamoDB object, which then allows us to run our commands here. So something interesting to point out is that inside of this serverless plugin code, we're actually able to run serverless.service.custom.stage. So the fact that we can go inside of the serverless.yaml file and then actually pull values out of it, like custom.stage, which you can see here, that's extremely powerful because that means that everything that's being listed here can actually be referenced inside of our plugin. So that's great. And then the code is equivalent to the original one if we run serverless copy -data -s production. Sweet. So I'm going to drink some water real quick, and then we shall continue. All right, perfect. So upload stage. Being able to choose which stage of the table to upload data will be a bit more tricky. In the original example, we're using a flag already used by the service. We now want to introduce a new one, and that's done by defining options. So let's look down here. We have the class, we have the constructor, we have our this.commands, we have our copy data command, we have lifecycle events, and inside of lifecycle events, we have download data and upload data. We have our usage. This is for running copy-data-help. Then we have our options. This is for, this is now an array. This is good to point out. So before this was an object. This is now an array. That means that we can have multiple options in here. So the first one, target stage you want to upload the data to. And then underneath that, assumingly, we'll have a source stage, right? So then your plugin can now say the target stage is production, the source stage is dev, and then it'll copy from production to dev, or vice versa. So now in the upload function, we update the table name the same way we did in upload. This time, however, getting target from options. So you can see here, serverless options resolve reject, serverless.variables copy data. So this is doing the copy data.items. This is after we do the DynamoDB scan. We then get back all of the records, and we're looping over that. We then create the parameters, but now we're doing it dynamically. So we're saying options, which is coming into this function, options target dash stage, and that will actually give us the proper stage, and that's just coming directly from the serverless plugin command. So I had to type this out just to show you what this looks like. So serverless copy dash data, and then we have target stage. There we go. And let's say that this one is prod. And so what's going to happen here is that this target stage prod is going to then be passed in to options. And then we can look it up inside the options object by doing options target dash stage. This thing is going to resolve to prod. And so then it's saying users dash prod. So hopefully that makes sense. And then it's going to then push it into that uploads, same as it did before. And data, remember, that's the array of promises which we covered up above. And so then finally you can see that here that we have stage, production, table, dev. So this is fine, but I would rather probably have two. I'd probably have two commands inside the plugin. A lot of times what I want to do is I just want to run, it's like copy, I want to run a plugin, and I don't want it to affect anything inside my stack. So I don't want to, but once again, you can reuse all this stuff, and this is for like showing the functionality. So in this case, it gets kind of confusing because -s production is being resolved inside of your serverless.yaml file, and then inside of the plugin, she's then referencing that. So then you kind of have two different places where information is coming from. You have one place which is coming from the plugin, which is -t, and you have one place which is coming from the serverless.yaml file, which is coming from -s, versus maybe both coming from the plugin itself. Which table? To get the right table, you can again specify an option and swap users for options.tablename. However, there's another way to do it that illustrates the capabilities of the serverless framework. Let's say you've defined your DynamoDB resource in your serverless.yaml file in the following way. So underneath here, you can specify regular CloudFormation resources. This is something, it's a common question for people that switch to the serverless framework, is what can I reuse that I already have, right? And the big thing is that you can reuse a lot of stuff. So this is a regular CloudFormation DynamoDB table definition written in YAML format. And if you keep scrolling down, this whole section here would be copy pasted from regular CloudFormation. So yes, the serverless framework adds additional functionality, but as you can see here, this is a very normal case. It's not like you're not creating a serverless framework DynamoDB table. You're just creating a regular DynamoDB table using the serverless framework. as the deployment mechanism. And then underneath that, you have table name. This is where we actually get into the benefit of using the serverless framework, that we can actually pass these dynamic variables. So this is regular CloudFormation plus dynamic variables, so self-custom.stage. So as we saw above, that would be production, so that would be passed here. Although the format of the table name is still name-stage, it won't work with our plugin because it expects a user table. So you remember up here, we hard-coded this, so users. But now what she's saying is that we created an articles table. So our plugin needs to both pass a target environment as our target stage, as well as a table. You add a new option called --resource that will point to the resource name. Then you get the right table name from its resource definition and can replace the original stage with the target one. So we look down here, get table name, and we can say table serverless.service.resources.resources. So what's happening here is that she's going into the serverless.yaml file now, and then saying resources.resources, then grabbing the table name. So the only thing, the asterisk that I would put here is I would say you probably wouldn't want to do that. Instead, and maybe I'm wrong, but you wouldn't want to do that. What you would probably want to do is move this table name underneath custom. So now underneath this custom, you would actually have something called table name or articles table name or something like that, right? And the reason why that you would want to do that is because then you can reference a table name in multiple places. So if we scroll back down, let's see if I'm wrong on this. I could be. What it says is serverless.services, service.resources, resources. So at this point, we're right here. And then options resource. So this is grabbing the resource name, properties, table name. Okay, so this options.resource, what that's actually referring to, it looks like, is articles table. So versus passing a table name like articles or a table name of just users, this is actually referencing, I think, this resource name here. So let's actually scroll down. Although this solution has its issues, it makes the plugin yet a bit more reusable and resilient. Yeah, it is a little bit, it does have a little bit of stuff, but it looks good. And then well done, you just finished the Serverless Framework plugin. Solves a real world issue. More to explore. So yeah, and then check out her GitHub. I'm not sure what's on there. Looks like it's the SLS plugins example that I just went through in that article. So this would be, let's just recap that real quick because I know that was a lot. Basically, the serverless plugin that was created allows you to copy data from one database to another, and it does that through using really cool functionality inside the serverless framework, which was pre-built for you to build plugins to extend that functionality. In this case, we're taking flags like -- resource, or we're taking a flag like -- stage or -- target source. And all these things are allowing us to pass dynamic variables into our stack. That way, when we actually create it, it can be reused by the community. So sweet. So that is the end of this. I'm going to stop the video here. If you want to learn more about serverless plugins or about building a serverless project, please check out training.serverlessfever.com and give us feedback, and then probably stay tuned because we're probably going to come out with more stuff soon. Otherwise, you can check out our YouTube channel or Medium. Let me show the Medium real quick. So our Medium is at Serverless Guru, and we've got a lot of articles covering different topics. One deep dive article that we did about a year ago today was on the serverless framework. So let's kind of scroll through here. You can see here we have like serverless real-time, React.js, AWS IoT, MQTT. Also have deploying an Angular app and AWS in seconds or 10 minutes. Serverless API with React.js. How to deploy a Flask app to AWS S3. AWS AppSync, fully managed GraphQL. Best practices for serverless deployment or development, if you're interested in that. And the list just keeps going. We have a lot of articles. I would definitely check it out, and then give us feedback. We get better, the community gets better, and everybody wins. So this was Ryan Jones with Serverless Guru. Thank you for watching, and I will see you next time when we actually get into building the serverless termination protection plugin. So, peace.